Hello, and welcome to the show. Today, we are messing with a lathe and a drill. We want this drill on center of here, so let's go over real quick how to do that. In your lathe, your machine spindle, the chuck in this case, super accurate, I know. The machine spindle is your 0 point. The center of that is your 0 point. This drill, probably a better drill than this, needs to be swept into center. What that means is you are putting your mag base indicator onto the spindle. You're spinning this by hand, or you can lock the C-axis and do it on the machine controller. But you are manually rotating the spindle slow speed to put this drill in Y center to the spindle and X center to the spindle. It honestly is that simple. But this is a hugely overlooked problem. The other half to that is live tooling. Live tooling, like in a mill, or live tooling on a lathe, if your lathe has it, does not make a center hole. It will drill on center. And after the first 50 thousandths of an inch, it might start walking. If this drill is spinning, and this drill is on center, it stays on center. If this drill is spinning and it starts to get off a little bit, it's now off center of the spindle. Conversely, if you have the spindle spinning and you're feeding with relation to this part moving, then even if this drill walks this way, the walls of the drill hole are in the way. It will want to cut in the path of least resistance. Path of least resistance on a spinning part is the center. It is literally that simple. There is nothing else to it. It does take time to figure it out, but it is that simple. Now, we skip to the Mizak footage. Roll tape. This drill's gone out. I need to resweep it. To resweep, put it back to the center of the chuck. Real quick, get the details out the way. This station is zeroed. This is zeroed to the spindle. The adjustable is a multiple piece holder that has 2 bolts in it. So you can move this thing in your X and your Y of the machine. So you can put your drill on center without having to adjust the computer. And right now, this one has to go. I'm just going to speed up this footage and get this over with. I need this thing running. But I'm going to take you off of the tool eye so I can set this thing. And I'll try to show you the drill. And what I mean by sweep, and what I mean by zero, and all that good shit. So, it's getting hard for me to see what this thing's seeing. To be honest, you guys probably see it better than I can. -1, 0. Up to 0. So, we're within 1 thou. I think I take it. Focus, you fuck. What you just saw me sweeping in was a carbide drill on a dual spindle Mazak machine. They do have other style of drills that use 2, 3, 4 inserts, a couple per side. Some of these can drill, and usually you want to drill them a little bit off center. These are indexable insert drills. They are not the replaceable tip, Ken tip, or the Ishkars. I don't know what they call them. But these can drill off center. You can use a 2-inch indexable insert drill, and you could realistically drill a 2 1/8 hole, as long as that center insert is still covering the center of the drill hole, so as not to leave a chip. And so you're actually covering your tool, not rubbing raw steel onto your drill, which, in case you're wondering, that is bad. These drills still need to be swept to center. You still sweep them into center. You still put them where they need to be in your tool data, in your tool offset page, depending on the machine you have. You will offset it in there. 20, 30, 40, 50, 60 thou. Whatever you need to move that drill. Mental note, if you tell the machine to move that hole 60 thou out, your machine might only move 30 thou. Why? Because it's accounting for, you want 60 thou on your diameter. So to move 30 here, 30 here. Or you have the other issue, the other flip side of that. You type in 60, it might cut the hole 120 thou. It might be over what you want. That is because it moved 60 thou in one direction, and there's 60 thou on this side as well. That is something to watch for. On the machine I showed you in the clip previous, that is how that machine is. If you tell it to move 100 thousandths of an inch, it's going to move 100 thousandths. That means on the diameter, it is now moved 200 thousandths. That is a big thing to watch for. That is very important, that you know what machine you're on, that you know how to program that machine. And if you don't know, if you're assuming, go get somebody. That is how crashes happen. That is how destroyed tooling happens. We don't want that. Take the time, ask somebody, make sure that you know what to expect your machine to do. I hope you guys enjoyed the video. Midwest Prick out. See ya.